Question number 11.15. Explain why is ortho nitrophenol more acidic than ortho methoxyphenol. So, to answer this question, first of all, what are the factors which influence acidic properties? So, first of all, it is when phenol is given to you, OH. Acidic property, that means how easily it can give proton. And by giving proton, it is forming phenoxide ion. So phenoxide ion is O negative. After that, the important thing is this bonding pair of electron between oxygen and hydrogen. This bonding pair of electron should be more towards oxygen. Then only it can give proton easily. And any electron withdrawing group from the oxygen will increase this property. That means any group which is electron withdrawing. Here in case of ortho-nitrophenol, nitro group if present here, that means at the ortho position, here OH is present. This is electron withdrawing group. So how it is withdrawing electron? Electrons are shifted to oxygen because oxygen is more electronegative, and this electron will come over here. And with this electron is going here, and this electron pair is coming over here, and with this the bonding pair of electron is going here and making the oxygen more positive. When it is positive, bonding pair is going towards it and making the hydrogen to remove easily in the form of proton. So any electron withdrawing group is taking out electrons from the oxygen. Whereas what happens in case of ortho methoxy. Methoxy group is this one and OH is here. So this is giving electron. Here it is giving electron, and by this it is increasing electron density at the oxygen. When electron density is more, bonding pair will not be towards oxygen and it cannot give proton easily. Whereas this can give proton very easily. So this is the first point. By that you can explain why ortho-methoxyphenol is less acidic as compared to ortho-nitrophenol. And second point is about the phenoxide ion. If phenoxide ion is more stable, then it will have this tendency to give the phenoxide ion and with that give the proton and be acidic. So why phenoxide ion is more stable? It is because of resonating structures. So that resonating structures you can make. Oxygen negative, and here at ortho position nitro group is present. So, first of all, this electron pair is shifted to in between oxygen and carbon, and then this electron pair will not be here and it is forming charge over this carbon. So we can make the next structure as here negative charge, here bonding pair of electron, here oxygen, and these bonds are not disturbed. Even the nitro group in the next structure. So it is up to here, and after that in the third structure, this electron which is present here, this electron pair is forming bond, double bond here, and this bonding pair will be forming charge over here. And with this, we can have third structure. Here charge appears, here double bond, and this part is undisturbed. Here also it will remain same in the third structure. Now for fourth structure, again electrons are moving to form bond between these two carbon atoms, and this bond is also shifted in between carbon and nitrogen, and this bond will not be here and it is forming charge over here. So this is how you can see that how the nitro group is helping in further delocalization. So in the next step, what are the changes we made? That is, this part is not disturbed and these electrons are as such, and here one bond is formed and this bond is not here and it is forming double bond in between carbon and nitrogen, and here single bond is left with the oxygen, and this oxygen with coordinate bond will remain as such. And by this, negative charge appears over here. So in the next structure, we have to shift the charge of the oxygen, and it is coming over here, and this bond is shifted in between these two carbon atoms, and this electron pair is going back to oxygen. So the structure, next structure should be single bond oxygen with negative charge over here, and this bond is not disturbed, it will remain same, and one bond is formed here and single bond is left over here, nitrogen, with double bond here, no charge over the oxygen, and coordinate bond with oxygen. So this is how all the resulting structures are possible, and nitro group resonating is further helping in making the resonating structure. And because of this, phenoxide ion is more stable as compared to phenol, and that is why it will have more tendency to give the proton that